If I told you that what we call a weak magnetic field might actually be just as powerful as an electric one, would you believe me? What if I said that the only reason electric fields seem stronger is because of the way we measure them, and that deep down, electricity and magnetism are really the same thing? Hey everyone, welcome to Mind Blown Science, your place for exploring the biggest ideas in science, physics, and mathematics. If you love learning about the universe, from quantum mechanics to cosmology, you're in the right place. Don't forget to hit subscribe so you don't miss any of our deep dives into the wonders of science.
So, are magnetic fields actually weaker? This question blew up recently on Reddit's AskPhysics, where someone asked, "I've heard that magnetic fields are weaker than electric fields by a factor of 1/c. Is that true or just nonsense?" And as always, Reddit delivered. Some users said yes, others no, and a few reminded everyone that physics isn't about catchphrases, it's about context. Let's unpack this with real physics.
The science behind the claim. In an electromagnetic wave, the electric and magnetic fields travel together, perfectly synchronized. Their magnitudes are related by a simple equation, E equals C times B, where E is the electric field in volts per meter, B is the magnetic field in Tesla, and C is the speed of light, about 300 million meters per second. So yes, numerically speaking, E is about 300 million times larger than B. That's where the idea that magnetic fields are weaker comes from. But hold on, this is just a matter of units, not actual strength. The energy carried by an electromagnetic wave is equally divided between the electric and magnetic fields. These share the load perfectly, so neither one is truly weaker.
The deeper truth. Magnetic fields aren't a separate weaker phenomenon. They're just electric fields viewed from a moving frame of reference. According to Einstein's theory of relativity, a moving electric charge creates both an electric and magnetic field. If you change your point of view, say you move along with that charge, the magnetic field can vanish entirely, and only the electric field remains. That means magnetism isn't weaker, it's electricity in motion. They're two faces of the same coin, electromagnetism.
When you hold a magnet near a paperclip, it feels gentle compared to the zap of static electricity from your sweater. That's because magnetic forces act on moving charges, while electric fields can yank on stationary ones. In our everyday lives, most charges we deal with aren't moving fast enough for magnetic forces to stand out, so magnetic fields seem weaker. But in a particle accelerator, or a fusion reactor, or even the Earth's magnetosphere, they can be massive in effect.
The takeaway is, so next time you hear someone say magnetic fields are weaker than electric fields, ask them, weaker according to what? The numbers or the physics? In reality, they're just two parts of one elegant system, one unified field pulsing through space and time.
If you enjoyed this deep dive, hit that subscribe button and keep exploring the universe with us here on Mind Blown Science, where curiosity never stops and the laws of nature are anything but ordinary.
References: Reddit thread r/AskPhysics. Magnetic fields are weaker than electric fields, 2024. MIT OpenCourseWare, Electromagnetic Waves and Energy Density. Physics.info, relation between E and B in EM waves. Maxwell's Equations, Foundations of Electromagnetism, James Clerk Maxwell, 1865. Albert Einstein, A, on the Electrodynamics of Moving Bodies, 1905.